So this is our second installment of Piecewise Functions videos. If you did not watch the first installment, I would advise you to do that now, and that will be linked down in the comments. And so what we did in that video is I gave you a graph, and I said come up with the equations. Now I've given you the equations. You have to graph it. Some people might say this is slightly easier than the other video. So what we're doing is we're taking these equations and we're going to graph them. And what I typically like to do is I usually put a letter next to each part of the piecewise function. So I'll call the top part A and the bottom part B. And then I'll go and I'll make a table for each. So make a little XY table. And then oftentimes what you'll see people do when they're graphing stuff is they go right back to their, what they learned when they were graphing was do -2, -1, 0, 1, 2, and so on for their table. And then they plug those in and they get their points. Well, that's not always the best approach with these examples. And the reason why is because this graph only exists on the left of -2. And so for x values, we're going to choose -2, and then any other numbers left of -2 are less than -2. So -3, -4, you can do some more if you want, but 3 points should give us an idea. And then we're going to plug those in. So we're going to plug those in for x into the equation. So we've got 2 times -2, which is -4, plus 1, which is -3. And we plug in -3. We get 2 times -3, which is -6, plus 1 is -5. Then we do -4 times 2, which is -8, plus 1, -7. And so we can graph these 3 points. -2, -3 would be right there. -3, -5 down here. -4, -7 right there. We can just keep using the slope to find our points. So oftentimes what I see when people start doing this is they'll connect the dots and they'll just draw a nice, beautiful line like so. That's not right. Why is that not okay? Well, because of what we said earlier. This graph is only defined to the left of -2. So we can't extend the arrow both ways. So what we need to do is we need to just stop the graph when it reaches -2. So our graph is going to be just this yellow graph here. I know it's a filled in circle at the end because of our less than or equal to. That tells me that this is going to be a closed circle. Okay, moving on to part B. So let's make a table for part B. X, Y. Now this time when we're picking x values, we're going to do -2 and above. Now I understand that this greater than means that -2 is not a number in that graph, but what we want to do is graph everything up to -2, so we will graph -2, but just do an open circle for this one. Because -1.99999 is on that graph, which is really, really close to -2. All right, so we're going to plug -2 in to the original equation in for x. -2 times -1/2 is 1, plus 3 is 4. And then we're going to pick numbers bigger than -2. So since we're multiplying by 1/2, I'm going to go up by even numbers, so I'll go 0 and then 2. 0 times -1/2 is 0, plus 3 is 3. 2 times -1/2 is -1. Plus 3 is 2. So I'm going to graph these, -2, 4, and then I'm going to do an open circle at -2, 4, because x is greater than -2. Then I'm going to go 0, 3, and 2, 2. And I'm just going to connect those dots, and I'm only going to have that graph go to the right, because that's only for x values -2 or above -2, not including -2. That's why there's that open circle. All right, so let's move on to example 2. It's just slightly more challenging. We have 3 pieces to this piecewise function. And just like before, I'm going to label these. We'll go A, B, and we'll do light blue for C. We're going to make a table. So for A, let's make a table, an XY table. And then for my X values, I want to do -2 and below. So I'm going to do -2, but then I'm not going to just haphazardly choose numbers below -2. I'm going to show you how we're going to use the slope to find our next points. So let's plug in -2. -2 times 2/3 is -4/3. And then we're going to add 13/3. And that gives us 9/3, which is 3. So our first point for that one is -2, 3. And then what we can do is we know that our slope is 2/3. And so that means that the x is going to increase by 3 because the change in x is on bottom. So we're going to go +3. That's going to give me 1. And then our y is going to increase by 2. So we're going to go +2. And that's going to give me 5. So the slope tells me the x increases by 3 each time. +3, which is 4. And then the y increases by 2, so 7. So I was able, instead of plugging stuff in, as long as I found one point, I could just use my slope to figure out the other points. So I'm going to erase this work here, and I'm going to graph these 3 points. -2, 3, and this time I need to be careful because that's going to be an open circle. So at -2, 3, I'm going to do open circle. And then oh, son of a gun. I messed up, didn't I? And the reason why is because I needed to go to the left. So let's be smart about this. We're going to erase these. See, even I make mistakes, which happens constantly. Oops, that's not what I wanted. There we go, there we go, there we go. So we need to use the slope still. But this time what we're going to do is not draw that line. Instead of going up 3 and up 2, we're going to go down 3 and down 2. -2 over -3 is the same as +2 over +3. So then we'd have -5, -8, and then 3 minus 2 is 1, and 1 minus 2, -1. So, like I said, we use the slope, but we just change the slope from 2 over 3 to -2 over -3, which is the same thing. So we go, the rise is 2, run is 3, so there's our next point. That's at -5, 1. And then we're at -8, -1, and we just connect those dots. So sorry about the boo-boo there. But that would be our first part of our piecewise function. We stop at -2, and then we move on to the pink one. So for part B, this table should be relatively easy, although I find that it's the most confusing for some people. The x values go from -2 to 3. So -2, -1, 0, 1, 2, and 3. And then the y values are just 2. This tells me that the y value is 2. 2, 2, 2, 2, 2. So we just graph all those points. -2, 2. Hey, look at that. Guess what happened? Oh, never mind. -2, 2. My lie. All of these are up 2. I was getting excited for a second. And then at 3, it's an open circle. So I'm going to do an open circle at x equals 3. And so it's just going to be a horizontal line up 2 until we get to 3, and then it's an open circle. All right, and then part C. Do that one in light blue. X, Y. And we need to pick x values 3 and above. So I'm going to put in 3. And I'll move down just a little bit. And I put in 3. I do 3 times -1/3. That's -1. plus 3 is 2. Come on. There we go. And then let's use the slope again. So this time we want our x's to increase. So we're going to go up by 1. And then our y's to go down by 3. We're going to use that. No, I'm sorry. I'm messing this up all over the place, aren't I? Remember, it's change in y over change in x. So my x's are going to go up by 3. And my y's are going to go down by 1. So down 1, up 3. So then my next point is going to be up 3 for the x, which is 9, down 1 for the y, which is 0. I'll get this right eventually. So we go over 3, up 2, and whoa, that pink open circle's there. But I need to do a light blue closed circle. So guess what happens? It gets filled in. So that open circle gets filled in, and then we go over 6, up 1, and then over 9, up 0. And I connect the dots. And voila. There is our piecewise function graphed in just a million easy steps. But just to summarize, make a table for each one, plug values in if you want to use the slope rather than plugging in value after value. Remember, it's change in y over change in x. Don't make the same mistake I did in this video. And adjust and then just go up on your table. Make sure that if it's going to the left, you're going down in the x value. If it's going to the right, you're going up in the x value. All right, so that is graphing piecewise functions.